Good morning, students. Today we see the important chapter, that is atomic structures. So, before to start this chapter, atomic structures, so we have to see what are the atomic orbitals. So, in the atomic structures, which are the important concepts, which are the terms, which are the useful for the studying the atomic structure. So, we have to see from the first point, that is first is atomic orbitals. In atomic theory and quantum mechanics, an atomic orbital is a mathematical function describing the location and the wave-like behavior of an electron in the atom. So about the atomic theory and the quantum mechanics, they have explained atomic orbital is a mathematical function describing the location and the wave-like behavior of the electrons in the atom. These functions can be used to calculate probability of the finding any electron of the atom in any specific region around the atom's nucleus. The term atomic orbital may also refer to the physical region or the space where the electron can be calculated to be the present as predicted by the particular mathematical form of the orbital. So these atomic orbitals, we can simply say that it is a region where the electrons are found around the nucleus. So in atom there is a presence of the nucleus is present at the centers, and the nucleus is surrounded by the different number of the electrons. So how we can categorize these atomic orbitals? We characterize or identify these atomic orbitals. That is it is a region, or there is a probability where the electrons are present, or the maximum number of the electrons is the found. So this is a region, it is called as atomic orbitals. Each orbital, again each orbital in an atom is characterized by the set of the values. Again these orbitals are characterized with the different set of the values of the three quantum numbers, that is n, it is a name as n, l, m, which respectively correspond to the electron's energy, angular momentum, and the angular momentum vector components. There is a magnetic quantum number. Alternative to the magnetic quantum numbers, the orbitals are often labeled by associated harmonic phenomena, that is x, y, x square, or the y square. And each orbital can be occupied by the maximum of the two electrons, each with its own projections of the sign. So in atomic orbitals there is a presence of a number of the sub orbitals, or it can be characterized with the quantum numbers. So there are the three quantum numbers, that is n, l, and the m, which gives the complete address, or the complete address of the electron where the electron is present in our atoms. And in every orbital there is a presence of only the two electrons. In one orbit we can present there is a presence of only the two electrons. So these again orbitals are the further names, that is simple name, that is s orbital, p orbital, d orbital, or the f orbital. So this s orbital refer to which angular momentum number l is equal to the 0, 1, 2, 3 respectively. These names together with range of the n are used to describe the electron configurations of the atoms. They are derived from the description by early spectroscopics of the certain series of alkali spectroscopic lines as sharp, principal, diffuse, and the fundamental orbitals are the basic building blocks of atomic model. The atomic orbitals are basic building blocks of the atomic orbital, alternatively known as electron cloud or the wave mechanics. So this in periodic table, all the elements are the arranged on the basis of the their atomic number. So this atomic numbers helps it is categorized, or its atomic electronic configuration is it is written on the basis of these quantum numbers, on the basis of these quantum numbers. So these electrons do not orbit nucleus manner of a planet orbiting the sun, but instead exist as standing waves. The lowest possible energy and the electron can take is similar to fundamental frequency of the wave on a string. So this is the wave-like properties. So again, next is the wave-like properties. The electrons are never in a single point locations, although probability of the interacting with the electron at a single point can be found from the wave functions of the electron. So it is next wave-like properties of this electron. Then particle-like properties are the number of electrons orbiting a nucleus can only be in the integral. Electrons jump between orbitals like the particles. So these electrons are also can they jumps from the one orbit to the next orbit. The electrons retain particle-like properties, such as each wave state has the same electrical charge as its electron particle. Each wave state has a single discrete spin up or the spin down depending on its superposition. So this is simple atomic structures. In a simple atomic structure, there is a presence of the electrons, protons, neutrons, and the electrons orbit. The electrons are the revolve around this nucleus, and the protons are the neutrons are the present in the center of the nucleus. The total mass of the nucleus comprises of these protons and the neutrons, and the electrons are the electrons revolve in the orbit. So number of the atomic number. So the orbits are number of the orbits are also increases. If atomic number is more, then number of orbits are also the more.